Derivative of y equals e to the power of x. So what is e to the power of x? Well, e to the power of x has a series expansion, which is x to the power of 0 over 0 factorial plus x to the power of 1 over 1 factorial plus x to the power of 2 over 2 factorial plus x to the power of 3 over 3 factorial plus x to the power of 4 over 4 factorial. You get a picture? Plus, and it goes on. So a factorial is that sign here. Let's write a couple of factorials down. 0 factorial equals 1. 1 factorial equals 1. 2 factorial equals 2 times 1, which is 2. 3 factorial equals 3 times 2 times 1 equals 6. 4 factorial equals 4 times 3 times 2 times 1 equals 24. So that's what factorials are. If we simplify this, this is what we get. X to the power of 0 plus x to the power of 1 plus x squared over 2 factorial plus x cubed over 3 factorial plus x to the power of 4 over 4 factorial plus, and it goes on. This is called series expansion for e to the power of x. And I can even simplify that further by saying 1 plus x squared over 2 factorial plus x cubed over 3 factorial plus x to the power of 4 over 4 factorial plus, and it goes on. So if I'm going to differentiate that, I have to differentiate all these. In this case, I need to differentiate those. But I'm going to use this one to do the differentiation, that one there, because it's the same thing as that. So to find the y over the x of e, because y equals e to the power of x, I'm going to use this formula that says that the y dx, just write it here, the y dx is n x n to the power minus 1 when y equals x to the power of n. So that's the dy dx. So I need the x in the power. That's why I'm using that. Even though that's a constant. A constant means it's the derivative with respect to x here. X is to the power of 0. That's why it's a constant. It could be 3 times x to the power of 0. That would be 3. If it's 1 times x to the power of 0, that's 1. So I'm going to use that. And then, so what I'm going to do is to differentiate y, I need to differentiate e to x, which means I need to differentiate all those. Okay, applying the formula here. So dy dx will be equal to, for that one, well, x, that's x, n is 0. So 0 times x, automatically the answer there is 0. Because 0 times x to the power 0 minus 1 is basically 0. So that one is 0. For the second one here is x to the power of 1. So that's 1 there. So 1 times x to the power of 1 minus 1. Well, 1 minus 1 is 0. So x to the power of 0 is 1. 1 times 1 is 1. Plus. Now, this one is x squared. So there's 2 here. So that means I need to bring the 2 down. So that's what I've done. So that's 2. So that'll be 2 Then I've got x, that's 2 now minus 1, so that's 1, over 2 factorial, plus, okay, that one, x cubed. So I need to bring the 3 down, so that's x cubed. Bring the 3 down, so that's 3 there. X, 3 minus 1 squared over 3 factorial, plus that one, 4. I need to bring the 4 down, so that's 4. 4 minus 1, x to the power 3 over 4 factorial, and it goes on. So what I do next is simplify this. So the y, the x equals to, well, 0 plus 1 plus, now 2 over 2 factorial. 2 factorial is 2 times 1. So there's 2 times here. So I'm going to write 2x over 2 times 1. That's what 2 factorial is. And you can see that the 2 cancel each other. So that's gone. So I just have x over 1 plus, well, 3x squared over 3 times 2 times 1. Well, the 3 will cancel each other. I'll just get 2 times 1. 2 times 1 is 2 factorial plus 4x cubed over 4 times 3 times 2 times 1. 4 cancels 4, and I've got plus. So I just got x cubed over 3 factorial. So 3 factorial is that. So I just got 3 factorial, 2 factorial, 1 factorial. Just bring this down. The dy dx will be equal to 1 plus just x plus x squared over 2 times 1 is 2 factorial. 2 factorial plus x cubed over 3 times 2 times 1 is 3 factorial. Plus, you can see what x4 will be, x to the power 4 over 4 factorial. Plus, and it goes on. When y equals e to x, the y, the x, it's same thing as e to x, because this is e to x. That's e to x, and that's e to x. So the y dx is also e to the power of x, and that's the derivative of e to x. The derivative of e to x is e to x.